So making decisions. If statements are one way to make a decision. Not counting while or other loops. Have we mentioned so far any other ways of making decisions? And my expected answer is no, but I may have thrown something in. Is there another way of doing branching? Not with loops, but besides if. What I'm thinking of is there's something called a switch case statement, which you may have hit in another language. We haven't hit it in this. I just wanted to make sure we hadn't hit it already, or else this chapter is going to be almost pretty much already. So, relational operators compare things, and we know what they mean. If A is greater than 10, if B is less than 7, if C is greater than or equal to 3. We already know what all that stuff is from grade school and junior high and stuff like that. We may not have used greater than or equal. It's been way too long since I took. Y'all did that? In grade school, up junior high, whatever. Yeah, you probably did. Except you drew it with the alligator mouth and then the line underneath it, right? Well, we can't do that. So we just do it like this. One thing to note is, what is the opposite of less than? It's not greater than. Just a second, I need to save this. This is somebody else's notes. So if you have if x is less than 10 and you wanted to write the opposite of it, it's not if x is greater than 10. That wouldn't work to catch everything that this one wouldn't catch. And why is that?
This is 10.
Yeah, what if it was exactly 10? So the opposite of less than is greater than or equal. The opposite of greater than, then, is what? Less than or equal. The opposite of equal. Grade school, we may have done that. I don't recall. But it's not equal. Or you can play with the idea of using an exclamation mark in a different way. You could also use it to make opposites. You could do this. If x is less than 10, if you wanted to do its opposite, you could do if not x less than 10. I don't recommend doing that. I'm not going to ask you about it. But if you ever see code that does that, just know that the exclamation mark at the beginning of it just reverses the truthiness of it. And in that case, you don't change it to an equal sign, right? This just flips the entire thing. To make it easier to read, you could do that. That probably makes it somewhat easier to read. A lot? No. Anytime you start throwing knots in, it makes it harder to read. So I don't recommend doing that. I mean, you could make things really hard if you wanted to. If not, x is less than 3, if, not x not equal to 4, you're just making things really hard on yourself. Okay, if we wanted to take that not out, what is the opposite of x less than 3? X greater than or equal to 3. And if you wanted to take that not out, what's the opposite of x not equal to 4? X equal 4. So that would be a far cleaner way to write it. And would you be tempted to throw in those knots anyways on your own? Probably not. So why am I showing them to you? You may see code written like that. Some crazy lunatic. Whoops, wrong window. That red icon. So these result in Boolean expressions, Boolean values. Relational operators, like less than, greater than, equal, result in Boolean values. It could be called Boolean expressions. Why? Because they evaluate the true or false. If x is equal to 3. It's either is or it isn't. Or if you wanted to store its result in a variable, if small x, bool small x is equal to x equal to 3. Like that. Same thing. And then you could do if small x. Then do some stuff. Still be true or false. These two lines of code here, or these two sets of code, that one compared to that one, do the exact same thing. Except this uses a Boolean variable to store the comparison before we do that. Are you going to do that? Well, maybe actually sometimes you will. This isn't one of those things where I'm throwing at you and then telling you never to do it. In this simple of a case, you probably wouldn't do it. You'd rather see that. But the expression inside there could be really complicated. It might have a whole bunch of different terms, you know, a whole bunch of less than's and equals and stuff like that, in which case storing it in a variable and then doing your if on that actually makes sense. Do not confuse equal and equal equal. If you do if x equals y, bad. Why? Because this would copy and erase the value of x, replacing it with the value of y. And then if x was a non-zero value, it would execute the block, the if block, no matter what. And if x and y were a zero value at that point, it would never execute it. It's completely wrong. It looks right, but it's wrong. So single equal is for assignments. Double equal is for comparing them. If statements, while loops, you know, that kind of stuff. Some languages don't even let the compiler try to do this. Java won't even compile if you type that. It thinks that that is such a likely mistake. But C and C++ don't consider it a terminal fatal error. The compiler may warn you about it, hopefully. But there could be some time when you actually meant to do it. I can't think of a reason why. It's almost always a mistake, and I've done that in code in the not too distant past, made that mistake, and it really frustrated me until I figured out what was going on. So the if statement. Branching, it allows statements to be conditionally executed or skipped over. Models the way we mentally evaluate situations. If it's raining, take an umbrella. If it's cold, wear a coat. If you're hungry, eat some food. If you're sick, stay home. If temperature is less than 0, whatever, you know. Flowchart. Is it cold outside? Yeah, sure is. Wear a coat. Quintessential branch. Is it cold outside? Yes. Wear a coat, wear a hat, and wear gloves. So this is a body of code with 3 statements in it. So we'd use curly braces to hold those 3 statements. If, curly brace, blah, 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 in curly brace. We are going to get through this fast. So I could throw if questions on it. Y'all already know how to use if statements. We've been using if statements all along from day 1, right? Okay, so it's not unfair. So if, this is a Boolean expression that has to evaluate either true or false, or at least 0 and non-zero. If the expression is true, then the statement's executed. If the expression is false, the statement is skipped. Average greater than 95. If your average is greater than 95, display congratulations. That's a high score. Kind of belaboring the point at this point. Guess what we're going to do next? The other branch. How do we implement the other side? Else. Right. All right, so important notes. Do not put a semicolon after the expression. And I just gave a quiz to my C# students, and a lot of them missed some questions, and I didn't mean for them to miss it, but I copied the quiz out of the book, and the book had questions like this. If x is equal to 3, print hello, or whatever word they used. They don't use C out there. Print goodbye. And the question was, if x does equal 3, what gets printed? And the choices were, does it print hello, does it print goodbye, or does it print hello, goodbye, or does it print nothing? If you know the answer, tell me. If you don't, that's okay.
Does the spacing matter?
It looks like it's going to print hello, right? If we had, you know, x is equal to 3 on the line above it, it ought to print hello. But these semicolons mess it up. What it really treats it as is that if x is equal to 3, do a little empty branch of code. And just because this is indented under it, doesn't make a lick of difference. Really, it's treated like that. So it would print both hello and goodbye. I'm not going to ask you about if statements with semicolons on the exam, and most likely. Might throw it on a quiz just to make you think. But I'm not going to do that. That's bordering on a trick question. Here was another one that was pretty, it's not as much of a trick question, but it was this one. X is equal to 3. X is equal to 4. If x is equal to 3, and it didn't have the semicolon to mess things up. Print hello. Print goodbye. And the answers again are, will it print hello, will it print goodbye, will it print both, or will it print nothing? It ought to print nothing, but doesn't have braces around it. So how's it really treated? If it doesn't have braces, only the first line is part of the if block. So it's indented wrong, really. Looks right to you Python programmers because indentation is all that matters to Python, but in this language that's not true. If you have more than one statement and you want it to be subordinate to the if, you've got to put braces around it. So if x is equal to 4, it's just going to print goodbye. It's not going to print nothing. Makes sense? Getting into subtleties there. Both of these are cases of syntax errors, almost. It doesn't stop the compiler, but you would never want to write that. And you would never intentionally indent your code like that unless you were a jerk trying to confuse somebody else, like your professor during an exam. I kind of doubt I'm going to do that.
Would that still print goodbye though?
Pardon me?
That, like how it is right now, would it still print
This would print goodbye. Right, this prints goodbye because even though this is indented the same, it's not treated by the computer, so we're indented. So since x is equal to 4, that's not true, so it would print goodbye. And if x was equal to 3, it would print both of them. Oops. Expanding the if statement. To execute more than one statement, you got to put them in braces. That was just what we were talking about. You take the braces off, that's not cool. This is conditional, but this is going to happen no matter what. It's going to print good job even if they made an F. They might like that, but it's not accurate. Your general rule of thumb is that if you have one line of code, it's okay to leave the braces off, but the recommendation is to go ahead and put the braces. Why? Because later on you might want to go and add more code. Makes it easier to add the code, makes it easier for somebody else looking at it to figure out where to add the code. But do you have to? No. And when I'm writing code up here, am I going to do that all the time? No, because I'm trying to get as much text on a page as possible when I zoom in the text. If else. The if else statement provides two possible paths of execution. If it's true, it does one thing. If it's not, it does the other. If Boolean expression is true, do that. If it's not, do that. So, is number %2 equal to 0? Notice Notice they put the true branch on this side rather than the false, just to mess with your brain. There's a professor here who says that true should always go off to the left no matter what. Most of the rest of us think that it ought to go off to the right. Why do I say that? Because what do you do when you're typing code and you have an if statement and then you have your brace? When you do, you tab, makes the code go to the right. So I think the true branch ought to be on the right. Whatever, not important, but we know the way this works. If you percent 2 and you, if you modulus it by 2 and you get a result of 0, what is that really checking for? Whether it's even or odd. Because you divide it by 2. If you divide by 2 and it's got a remainder, it's an odd. But if you divide by 2 and there's no remainder, then it's an even. So you would write this, if number mod 2 is equal to 0, print even, or see out even, else see out odd. Testing the divisor. Alrighty. This program asks a user for two numbers, num1 and num2. Num1 is divided by num2 and the result is displayed. Before the division, however, num2 is tested for the value 0. If it contains 0, the division does not take place. Alright, why would you write code like this? Cout, enter x, cin into x, cout, I've got these backwards, there we go. Cout, enter y, cin into y, if y is equal to 0, cout, can't do it, else cout, result is, I'm going to do that, like that, and inside those parentheses we're going to put x divided by y. Why would you bother putting this inside an if block? Why do you even check to see if it's equal to 0? You can't divide by 0. In some languages you can, and it says the result is infinite, kind of a mathematical thing. C++ and a lot of other languages will just generate an exception, generate a runtime error. Your program will crash right at that spot because it doesn't mean anything. If you have a pie and you divide it up among 0 people, how much pie does each person get? Doesn't mean anything. So this is using an if statement to make sure that there's not an error condition. And if there is an error condition, we print, you can't do that, else you go ahead and do it. And we could have swapped it. How would we revise this if I wanted the error message to be in the else? If I cut that, paste it here, and then I cut that and paste it here, what do I have to change my if condition to make that work? Yeah, if y not equal to 0. There we go. That's probably how I would do it, actually. I like my error message. Well, I can't say that. Sometimes it's nice to have the error message on the top just to rule it out. If you have a whole bunch of code, right? If this code is 10,000 lines long, it'd be nice to have the error condition first and then do the else 10,000 lines of code, in my opinion.
Do they have to be in separate brackets?
Do they have to be? No, because they're just one line of code. If you only have one line of code, you can leave the brackets off. That makes sense? Nested if statements. That's an if statement inside an if statement. You can use them to check more complex logic. If, say that in order to earn our special reward, we have to have been in the service, so vet is equal to true, and there's got to be some other case. I don't know why. Okay, this one's failing me. I'm not coming up with a good one. Okay, so you have to be a recent grad And, why is my brain freezing on this?
You do like 11 or something like that.
Yeah, okay, if you have money, and if you have hunger, then print, go eat. You could express that with a nomenclature known as and, but more fundamentally it's this. If money is greater than 0, if hunger is greater than 0, then print. Go eat. Go out to eat. Alrighty, we could expand on that to some other conditions. What if you don't have any extra money? We could add an else clause down here. Else, see out, better stay home. Right? Why am I using print statements? I'm stuck in Java. I'm probably going, what is he doing? Okay. There are print statements in C as well, but they're called printf. We don't teach them really. They're old school, old style. All right, and what if you're not hungry? Then we're going to print save your money. Now this still doesn't count every case, right? This doesn't count if you're hungry but you don't have money. Kind of a three-way logic rather than a four-way. Anytime you have two variables which are independent of each other, true, false, you really have four states. You have money or no money. You have hunger or no hunger. You know, that's a grid, a 2x2 grid, which makes 4. But according to the way I did this logic, there's only 3 possible states, and that's because I didn't put another nested if here. But this is an example of a nested if right here. This if is inside the other if. Makes it a nested if. Is there another way to word this? Yeah, you can use the and symbol to do that. Have we done and yet? And an or. Alrighty. You have to look at the people who haven't taken my other 2 classes. Some people sit through like 5 hours of lecture from me, and I don't know how y'all do it. So, are you employed? Yeah. Are you a recent grad? Yeah. Display, you qualify for the special interest rate. So this bank's giving away money, better interest rates if you are employed and if you're a recent grad. Which isn't really fair if you're employed at a very gainful job, but you're not a recent grad. But anyways, display, you must have graduated from college in the past 2 years to qualify. That's what happens if you are employed, but you're not a recent grad. Just like ours, do you have money, but you're not hungry. And if you're not employed, it says you must be employed to qualify. So this is the nested if part of it, because this if statement is part of this. Nested, like nesting dolls, Russian dolls, where you have the little doll and then the bigger doll and the bigger doll. Use proper indentation. Okay. If, else, if. Sometimes you don't only have 2 conditions. Sometimes you have 3 conditions. If grade is greater than equal to 90. You know, see out. I'm sure we did something like this, right? We do this one? Didn't do this? Alrighty. Else if grade is greater than or equal to 80. See out. You made a B. Else, see out. You fail. This is a really rough grading system here. If you don't make an A or a B, you're in trouble. Your parents are really stern. Anyways, so if do this. Else, if, do this. Else, so we have three cases, right? If you make a 90 or above, you're in A territory. If you make an 80 or above, you're in B territory. Otherwise, you're not. And you can chain as many else ifs as you want. Else if grade, is greater than or equal to 70. Else, in fact, that's going to be our assignment. Write a grade program that prompts the user for a numeric score and then prints their grade based on the following grade scheme. '93 and above is an A+. 90 below that but above 90 is an A-. If it's 87 or above, it's a B+. If it's an 83 and above, it's just a B. If it's an 80 or above, it's a B-, else fail. Like that. So those are the grade ranges. Right? So if it's 93 and above, print out A+. Else if it's 90 or above, B-. Else if it's 87 or above, and you're going to have to be careful. It's a B+. Or if it's 83 or above, and I'll tell you why you have to be careful. I'm going to write this in the wrong way. Else fail. What if we did it like this? What if we just took this logic up here? I'm going to rewrite it. If grade is greater than or equal to 90, print A. I'm leaving off semicolons and braces and everything. Else if grade is greater than or equal to 80, print B. Except, what if I left the else off? And then if grade is greater than or equal to 70, looking good. C out, C. And then else, C out, F. At first blush, it might look like it does the same thing, except I added C as well as A and B. But does it do the same thing? What happens if their grade is in fact a 91? What is it going to print? Goes here. Grade's greater than or equal to 90, so it's going to print an A. Great. Then it goes here. Is our grade greater than 80?
Yes.
Yeah, so it's also going to print B. Then it's also going to print C. The student probably didn't want to see that they made an ABC. So that's why you use else's. Else's make it mutually exclusive, Only one of these things is going to happen. Is your grade greater than or equal to 90? It sure is. Then skip everything else. Hope that makes sense. Bad logic. If they scored a 90 or above, it would print A, B, C. That makes sense? Give me jazz fingers if it doesn't. Alrighty. Wrong. Right. So test a series of conditions until one is found to be true. This is often simpler than using nested if-else statements. Model thought processes like if it is raining, take an umbrella. Else, if it is windy, take a hat. Well, what if I wanted to take an umbrella or a hat? Else, take sunglasses. Okay, I don't think that's the best example, but you get the idea. If it's above 100 degrees, wear light clothing. Else, if it's above 30 degrees, wear long sleeve shirts. Else, wear a parka, something like that, where you have three different cases. And my classic one is for temperatures, the freezing point and the boiling point in the Fahrenheit scale is 212 is boiling. 32 is freezing. So, right, if the temperature is greater than 212, see out boiling. Else, if the temperature is less than 32, see out freezing. And then our third case, else, see out liquid. And you can have hundreds of else-ifs if you need to. If you have hundreds of else-ifs, you're probably going to use a different structure known as a switch statement, which we will get to in a later slide, I'm absolutely sure. Keep doing that. So the syntax, if expression, do something. Else, if expression, do something else. Else, now you could word these differently. I've seen students who want to implement this logic, and it's not incorrect. What if you did this? If temperature is greater than 212, see out boiling. Else, bracket, if temperature is less than 32, see out freezing. Else, see out liquid. Conceptually, they do the same thing, other than the fact that I've left semicolons off everywhere. Right? We've got an if statement nested in the else clause. Works, but which one is easier to look at? Do you like that one better, or do you like that one better? If you have a preference for the second one, go for it. But if you had more else ifs, they would keep getting more and more indented, right? You have to keep, doing, a block here and put another if statement inside it and so on. So that's why you have ElseIf. And for you Python folk, you used it ElseIf. I'm sure you remember that. All right, so wave your hand. Who likes this method? It's okay if you do. Yeah, we all hate it. Okay, no, don't do that. Well, this code goes a real long way towards showing you how to solve the homework I'm going to give you. Can you do these things in other ways? Yeah, sure you can. What if I wanted to do this? I'm going to delete the bad one. Without using else's. If temperature is greater than 212, see out boiling. You could do this. If temperature, and this would require us to know what and means, is less than or equal to 212, and I'm going to use the word and now, but that's not actually the correct symbol, and the temperature is greater than 32, see out liquid. And if the temperature is less than or equal to 32, now I'm kind of messing up my boundary conditions, but anyways, see out freezing. You can try to fake it. You can try to get away from using else's by using and statements. Now, and is actually represented in this language by 2 ampersands, like that. I don't recommend doing that. So if you find you're writing your grading program like this, if grade is greater than or equal to 80 and grade is less than 90, that works. But try to get around from using the double clauses in your if statements. Instead, just use else's and have single comparisons. So, if your test score is greater than an A, print your grade is an A. Else, if your test score is greater than a B, print your grade is a B, and so on, all the way straight down. It's always a good idea to throw in a final terminating else. Even even if it doesn't seem like you need one. In my case, these examples, I would just say else your grade is an F, right? Because if none of the other choices are true, you know it's an F. But this programmer thought that it'd be a good idea to make it print out an error message if the score was negative, and so they threw that in. A final else statement. Why? Because if none of these conditions are true, even if you were absolutely sure that would never be the case, you want an error message to be printed out so that you can go back in and fix the logic later. Because maybe you didn't handle everything. Maybe you only thought you handled everything. Maybe you forgot to do the C-score one, you know? Or you forgot to do this test score is greater than or equal to 0 or whatever. Always a good idea to put a trailing else if you have a whole bunch of else ifs, even if all it does is print unexpected state or something like that. Flags. A flag is a Boolean variable. You remember when I did that example, small x, and I did small x is equal to x less than 3? That's known as a flag. A bool is a variable that can equal either true or false. You could do this. Bool freezing is equal to, and I'm going to put parentheses around it, but you don't have to. Temperature is less than 32. And then bool boiling is equal to temperature greater than 212. Then you could do this. If boiling, if boiling, see out, boiling. Else, if freezing, see out, freezing. Else, see out, liquid. Now that's up to personal choice, whether you like doing that or not. Do you like this syntax better? You calculate your conditions beforehand and then you make your decisions based on them and they look all tidy like that? It's okay looking to me. To me, it's just as clear pretty much seeing that temperature greater than 32 if we put that right in there. I'm not really expecting anybody to implement it in this fashion where you use flags, but you can. Did that make sense though? A flag is a Boolean condition, a Boolean variable that is checking a condition, and then you can use that condition in an if for a while statement, flagging whether it's true or not. If I'm out of gas, right? If gas equals 0, out of gas is equal to true. You know, so low bool, low gas is equal to gasoline less than 0.1 gallons. If it's less than 0.1 gallons, you're in trouble, right? And then if low gas, you know, show the warning light. Like that. Why might you want to do that? Well, maybe you just want to make it easier to spot your conditions. You know, if you're going to make this Celsius instead, you wouldn't use 32 and 212, you'd use 0 and 100. So, this text says that you can use a flag as a 0 or a non-zero, where 0 is considered false and a non-zero value is considered true. That's old school C programming from the 70s. If you have a Boolean variable type, I recommend you use it. Logical operators. Well, we had our relational operators, less than, greater than, things like that. We also have logical operators. We have and, or, and not. And means both sides of it have to be true. If money is greater than 0 and I'm hungry. See out, let's go out to eat. Right? Both of them had to be true before we could go out and get pizza, unless you have a friend you could mooch off. You know? So, if you don't have any money, it doesn't matter how hungry you are. You're not going to go out for pizza. If You have lots of money but you're not hungry, there's no reason to go out and get pizza. So and means both sides have to be true. And both operands, both conditions have to be true. And in this case, the operand is an entire logical expression. So you could build what's known as a truth table. And. So like x and y result. I'm just going to use T and F for true and false. If they're both true, the result is true. But if either one of them is false, the result is false. Even worse, if both of them are false, the result is false, right? Because if you don't have any money and you're not hungry, you're certainly not going to go out to eat. So this is the and truth table. Or is a different symbol. Or is represented by shift backslash, the two vertical pipes, bars, vertical lines, however you want to say it. Either one side, either side can be true for the result to be true. And that's a little bit different. If your tiredness is greater than 0, or your sickness is greater than 0, see out, better stay home. That's a good way to get fired, right? You stay home just because you're a little bit tired. But I'm going to change these to just Boolean variables rather than expressions. So if you're tired or you're sick, you stay home. That's an or. You don't have to be sick and tired to stay home. You have to be one or the other. Or what if you're going to decide whether you can sleep in late? And there are two possibilities for whether you sleep in late. It could be the weekend, or you could be on vacation. Or you could be sick. Let's throw in a third one. So if weekend or vacation or sick, see out, go ahead and sleep late. So the truth table for or looks a little bit different. Truth table, if either side is true, then the result will be true. I'm just going to copy and paste this one and make the appropriate modifications to save time. So x or y and the result. All right. Is either one side or the other true in this top case?
Yes.
Yeah, they're both true, so we're doubly blessed. How about, yeah, that it certainly got at least one true. We're good to go. How about that one? Yep. And lastly, no. So notice here that the and only has one possible true case, and that's when both values are true. Or only has one possible false case. And I'm going to veer off suddenly towards a point that I sometimes forget to make. If you think about this, if you had math that looked like this, 0, well, 1, 1, 1, 1, 0, 0, 0, 1, 0, and 0, 0, 0. And you wanted to fill in a mathematical symbol, either addition or multiplication. What would you put here to make these four conditions true? Would you use addition? Or would you use multiplication? You'd use multiplications because although 0 plus 0 is 0, 0 plus 1 is not equal to 0. So in logic terms, if you ever take a discrete class or a logic class, you would say that and is equivalent to multiplication in Boolean math. And then the or table 1, 1, 1, 1, 0, 1, 0, 1, 1, and then 0, 0, 0. This is OR, which is known as logical addition. 0 plus a 0 is a 0. 0 plus a 1 is a 1. A 1 plus a 0 is a 1. And a 1 plus a 1, well, that ought to be a 2. Well, in logic, something is either true or false. It's only got a 0 or a 1. So you could say that OR can be represented by a plus, and can be represented by a star. And I don't really think we need to get any farther than that. And along with and OR, we have not. Like on the Colbert report, he was always talking about the truthiness. Not reverses the truthiness of it. If you had something that was true, but you stick an exclamation point in front of it, it becomes not true. And I showed that with that if statement. So if you have this, x is equal to true, y is equal to false, and then you have a is equal to x and y. You have b is equal to x or y, and you have c is equal to not x, and you have d is equal to not y. What is each one of those equal to? Well, these are the easiest, right? They just flip the value. So if y is false, what is not y? It's true. How about this? X is true, so not true is false. Now we have to remember our AND rules. Is this true or false there? For ANDs to be true, both operands have to be true. Are both operands true? No, so that's definitely a false. How about OR? This is an OR, so only one operand has to be true. So that's definitely a true. And here they're doing the same thing, except they're actually doing math inside the parentheses rather than just variables. Okay, we can do some of those. X is equal to 1, y is equal to 2. If x is less than 10 and y is greater than 3. If, or let's just do this, yeah, a is equal to that, b is equal to x less than 10 or y is greater than 3, c is equal to x less than 10 or not, I'm going to mess this one up, if y is greater than 3, keep changing my mind, less than 10 and not y is greater than 3. Let's figure out what x, b, and c are in this case. Well, is this part true? Is x less than 10? Yeah, that's true. Is y greater than 3? So, and this is an AND, which requires what? Both sides to be true. So, were they both true? They were not both true, so that's a false. How about this? X less than 10. We decided that's true. Y is greater than 3. We decided that's false. So if we OR them together, only one side has to be true for the answer to be true. Was one of them true?
Yes.
Yep, so that's a true. And what about this last one? Is x in fact less than 10? Pass this 3 times. Yes, it is. How about is y greater than 3? But there's a not in front of it, so that makes it true. So this is true, that's true, so that becomes true. And maybe you can see what I mean. When you start throwing nots in, it starts messing with your brain. Like, you know, if you're speaking English, you're not supposed to use double negatives. It can make these sentences harder to read, to understand. You know, in the simplest case, you know, it's not too bad. But by the time you start saying, okay, how about just, we don't need no education? Does that mean they do need education or that they don't need education? So if you say, we don't need no education is the absence of education. We don't need an absence of education. So we don't need an absence of education makes it sound like we need an education. And that's a silly example because it's slang, right? You know, we don't need no whatever. You understand it, even though if you expressed it logically, it means the opposite of what you're saying, and that's a double negative. Where was I going with that? Why did that? Oh yeah, so don't throw in a whole bunch of nots into your code if you can avoid it. Instead of writing not y greater than 3, how could I rewrite that to take that out? I'd want to change the symbol to its opposite. So what is the opposite of greater than? Less than or equal to, and that's all of a sudden much easier to read, right? In my opinion. I'm going to change it back to the way it was. We absolutely are going to finish this lecture by the end of the week. Okay, so logical operator nodes. Back into precedence. Precedence isn't only PEMDAS for mathematical operators. Other operators have them too. Parentheses still override everything. But then there's not, which has the highest precedence, followed by and then or. And that's actually important. What if you wrote this? If x is less than 10, or, why did I say x? Or y, b is equal to 1, and c is equal to 2. Does that mean that you solve it left to right? If a is less than 10, great, but if it's not less than 10, then the whole thing's gone? What you've got to do is remember how we said ands were like multiplication? Multiplications have higher precedence than additions. So you'd have to do this part first. You'd have to check to see if b is equal to 1 and c is equal to 2. This has to get evaluated, and then it can be ORed with this. So precedence plays a role in logic just as it does in math. So you still have parentheses up at the top of the list. But then you have not, and then you have and then you have or. And you can probably remember that because and is equivalent to a logical multiplication, and or is equivalent to a logical plus. I don't recall asking that on any of my quizzes. If you ever have any question about it, put parentheses. If you're not absolutely sure what this is going to do, or if you think somebody else is going to look at your code and they're not going to know what to do, it'd be better to add parentheses to make it clear. That makes a stone cold clear, right? Was it necessary? No. Just like if you had, 3 times 4, do you have to put that 3 times 4 in parentheses? No. The computer would do it anyways. But it makes it easier for a programmer to read, for a human to read. The only time you need parentheses is if you're clustering it in a way that precedence wouldn't support. Like if you wanted this to be done before you anded it, then you would use parentheses. Checking numeric ranges with logical operators. Remember when I was doing less than 32 and greater than 212? We can rewrite those with ands and ors. Checking numeric range. Use and to see if a number falls within a range. Use OR to see if a number falls outside a range. Like this. If temperature is less than 32 and temperature is, temperature is greater than 212, then print it's not liquid. That checks to see if it's in a range. That checks to see if it's between 32 and 212. I forgot my punctual symbol. Comparison operator. If you're going to check outside the range, though, what am I doing? I'm going to rewrite this. My brain went into la-la land. I like this example better. The other one was still valid, but I think it was real bad. Okay, let's go back to it. Tell me what is horribly wrong about this statement here. And it is horribly wrong. Will it ever print anything? Can a number be both less than 32 and greater than 212? No. So that was a mistake. I goofed on that. I should have made it if greater than 32 and less than 212, print it's a liquid. So we checked to see if it was within a range. Now let's check to see if it's not within a range. If temperature is less than 32 or less than or equal to, if we actually wanted to make it, the exact opposite, or temperature is greater than or equal to 212, we're outside of the range. See out, it's not a liquid. That makes sense? To check to see if it's within a range, you use AND because you want to make sure that both cases are true. If you want to see if it's outside of a range, you use OR, and you check to see if it falls outside of your range. Are we good there? I think so. Menus. Menus, when you list a list of choices, press 1 to add, press 2 to subtract, press 3 to, and we haven't done a program yet, so let's do an itchy-bitchy little menu. And then we'll make that our daily assignment, and we'll be pretty much done. Let's make a new project, an empty C++. October 3. Go and grab your boilerplate or whatever you like to do. Include IOStream. Oh, by the way, if you're doing this stuff on a Mac, you don't have to do the system pause at the bottom. Because you probably already noticed that when you run an Xcode, it leaves your output there anyways. The only reason we're putting system pause at the bottom is to try to stop it from closing the windows. There are other ways of getting it to stop from closing the windows anyways, even if you're doing it on Visual Studio. But you certainly don't need it on your Mac. Okay, so if I wanted to follow all my rules for about what to include, I'd also get CMath. But this one's not going to do much math at all. Then using namespace std int main. I need my system pause here. PC users only. System pause, and then return 0. All right, now let's actually put some code in here. All right, when they show their menu, I really don't think you ought to introduce the concept of menus until you do while statements, so that you could loop the menu over and over and over. So this is going to be a really dumb program. if we don't use a while. But so be it. Cout. A for awesome. Told you it was going to be stupid. Okay, let's do something a little bit better than this. All right, let's do some elements. H2, like the gas hydrogen. And then Cout O2, like the gas oxygen. And then Cout CO2, carbon dioxide. But let's give them some choices. 1 for H2, 2 for O2, and 3 for CO2. Now let's read in a choice. We could store the choice either in a string, which I forgot to include up there. I always include string, and the one time that I needed, I didn't. So anyways, let's declare a variable called choice. We can make it an int, we can make it a float. Let's read in to the choice variable, and then we'll use some if statements. So if the choice is equal to 1, we're going to write out a message. We're going to write atomic mass of H2 is 2. The chemistry guys will tell me that's not quite right. It's 2.00, whatever. Else, and you know what? I'm going to take the braces out just because I can get more code on the screen. Else, if the choice is 2, Cout atomic mass of O2 is 16. Thank you. /n. Else, now I could just say else atomic mass of CO2. I'm going to go ahead and do that, but then I'm going to make a correction. I'm going to make a change. Atomic mass of CO2 so it's 6 plus 16, 22. That's not sounding right to me. It's 12 plus 16 is 28. Who cares? Alrighty. Maybe just looking at it, you can guess what I don't like about this program. No, wait. I don't think the atomic mass of O2 is 16. I think the atomic mass of O2 is 32. And then the atomic mass of CO2 is 44. I don't know, some of y'all are saying, who cares? But I wanted it to be right. Okay, but what's wrong with this program from my point of view, even if you don't really think so? What if they type in 0? Do we want to print out atomic mass of CO2 is equal to 44 even if they typed in a 0 or a 10 or a million? No, we really want to kind of be precise. We want to make them enter the correct choice and then display an error message if they don't. So I'm going to modify this. It's not just going to be else, it's going to be else if choice is equal to 3. Cout the atomic mass of CO2 is 44. And then I'm going to use a final trailing else, just like I mentioned. Invalid choice. So does that make sense why I made a choice is equal to 3 and then I added that final invalid choice rather than just saying else atomic mass of CO2? Y'all good with that? Reason we do that is so that we're making them pick the valid choice to trigger that action rather than just saying, oh, if they choose anything else, we're going to tell them what CO2 is. Let's run it. And by the way, guys, if you do this start without debugging, it shouldn't require the pause statement. But there's a time when you want to run the debugger, so I go ahead and stick the pause in there. So I'm going to type in 12. It says invalid choice. Good enough. What would be really cool is if it looped. Put it inside a while loop. I'm going to run it again. I still don't think it paused. Or didn't not pause. 3, atomic mass of CO2 is 44. Test the other two, then it's done. Alright guys, so as mentioned, there'll be that homework assignment for the grade system where you can make an A+, A-, you know, stuff like that. I'll go ahead and post that as an official looking assignment. Does anybody need this code up still? Yeah, I see some typing still. Alright. Alright, but I'm going to stop the recording here and make the Dropbox.